problem. So Leetcode 29:19, minimum increment operations to make array beautiful. So for this problem, we are giving an integer array nums, and for nums I, it's going to be more than or equal to 0, less than or equal to 10 to the power of 9, and the length of the nums array is going to be more than or equal to 3, less than or equal to 10 to the power of 5. Yeah, so if it is like that, maybe we can solve this problem by O n time or n log n time. Yeah, but what we are giving is just we need to check the maximum number inside a window. So the window size is going to be 3. Yeah, so here said if any array is considered beautiful, for any subarray with a size of 3 or more, its maximum element is greater than or equal to k. So how would we consider 3 or more? Is that 3 enough for us to solve the problem? I mean, if we consider the window size 3, yeah, if the window size of 3 meets the conditions, definitely, if it is more, definitely it meets the conditions. So what I mean is that, so for example, this is window size 3, 3, and 3. If the 3 meets the conditions, definitely the 4 meets the conditions. So this means we don't need to consider the window size like 4 or 5. We only need to consider the window size which is going to be, which is going to be 3. Because this is enough. If 3 meets the conditions, definitely 4 or 5 or more meets the conditions. This is another way to make the problem simpler. Yeah. And instead of going forward, we're gonna start going backward. So we're gonna start from the right side. Yeah. Basically, giving any array. So for 2, 3, 0, 0, 2. Basically, we have two decisions. Yeah. We can choose this number to be the maximum number, or we will not choose it as the maximum number. But what is the difference between the two decisions? If we choose this 2 to be the maximum number, what's going to happen is, what is the distance from this k to 2? So k minus this 2 is going to be 2. Yeah. So this means at least we're going to need 2 operations. Yeah. So if this number is selected and we're going to make it to be the maximum number, this means for the next 2, normally we don't need it. Yeah. But we can still choose to make it to be the maximum number because we are not sure. Yeah. So the problem is that if we choose this to be the maximum number, so for the next one, we can decide to check the minimum between this one and this one. This one we can decide to make it unchoose. If it is unselected, what happens for the unselected? This means we just need to shift the index. For example, this is the index I. We just need to shift the index I to I minus 1. Yeah, but this means we need to find a distance. So for example, this index, for example, we're going to check a distance. We're going to set it as 0. So currently this distance is 0. So this means for distance 1, 0 to 1, or 0 to 2, it always works, even when unselected, because this one is selected. Yeah, and similarly, we're going to shift it. Yeah, let me go back. If this one is selected, what's going to happen? Yeah, because definitely this one has already been chosen, and this problem has been solved to be a sub-problem. Yeah. Now we can even decide to choose this one. So if this one is so if this one is selected, what's going to happen? This means for the next 2, it can be unselected, and similarly for the next one. Yeah. So yeah, let's just try to go through this problem according to the first example. So if this one is selected, we need 2 operations, right? We need 2 operations, and this means the next 2 will be unselected. It might be a minimum operations. Yeah. Now we're gonna shift this one. So what is the meaning of this one? The meaning of this number is the number from the right of the window. So the window size is going to be 3. So this number is going to be at the end of the window. So this 2 is chosen or not chosen. But currently we need 2 operations. So this means this one will not be selected, and this one will not be selected for the maximum number. Yeah. But what about if it goes here? If it goes here, it means that it goes out of the window because the window size is 3. If it goes here, it means we goes out of the window, because here is 0, here is 0. Maybe we're going to choose this one to be the maximum. So this means k minus 3, it's going to be 4. K minus 3, 4 minus 3 going to be 1. We still need one operation to be the maximum. So this one going to be 4, and this one going to be 4. Yeah, and continually for this one, we can decide to choose it or not choose it, but we're going to choose the minimum operations. Yeah, so currently if this one is chosen, this means this one cannot be chosen. Yeah, so this means there are going to be 0 operations. Or you can choose it. It's going to be 2 operations, but we're going to choose the minimum of the 2. 0 and 2, minimum are going to be 0. So in total, the operations are going to be 1 plus 2. It's going to be 3. It's going to be the minimum operations. Yeah. So basically, if you understand the dynamic programming idea, and if you know that definitely we're going to solve it by using dynamic programming, you might think about an idea of how to solve it. Yeah. So I means the index of the nums array, and j just means j just means the number of the distance. J just means the distance from the current number. According to our problem, the size is 3, or j can be understood as the size of the window. This means the window size will not be more than 3. If it is more than 3, we're gonna make a decision. We have to choose a number. Yeah, if it is less than 3, we can unselect it. If the index is less than 0, we're gonna return a 0. This means it is not possible, definitely. So yeah, we're gonna return a 0. Otherwise, we're gonna prepare the result. It's gonna be DFS. Yeah, currently for the last number, for example, this 2, definitely we're gonna choose it. Yeah, so if we choose it, it's gonna be I minus 1, because we're gonna start from here. So n gonna be length of the nums, and we're gonna return something DFS with n minus 1 to 0. So this 0 means from the beginning, the distance with this 2 and 2, the distance is gonna be 0. Yeah. So currently, for our result, we can decide to choose this first number. Yeah, because normally for this first number, it is okay. So we can decide to the first number. I mean, from the last one, this number is gonna always be chosen. So we're gonna, from the beginning, we're gonna choose this number. So if we choose this number, it's gonna be I minus 1, and j gonna be 0, and we're gonna set the distance to be 0. So if we choose a number, we're gonna set the distance to be 0. The window size to be 0, and then we're gonna check the maximum, because if we choose a number, it's gonna be at least 0. Maybe this number is 5, so it means yeah, the operations are gonna be 0. We don't need to do anything about it. But what if this number is too small? This means k gonna be minus this number, nums I. Yeah, so this is for select. This means if we select the current number, we're gonna set the distance to be 0. This is very important. And we're going to go to the next number. It's going to be I minus 1. Yeah. Now, for the next 2 steps, we can still unselect it according to the value of the j, according to this distance of the j. So if the distance is less than 2, it means still we can unselect it. So we're going to choose the minimum of the result. So this is a select for the current index I, and for the next 2 index before this I, so this is I, for the next 2 index I minus 1 and I minus 2, we still have the opportunity to unselect it, but we can still select it for the next time, because for the next time for here we can also select it, but we still have more opportunity to unselect it, but we're going to choose the minimum of all the possible results. So for the next 2, we're going to unselect it. If we unselect it, it's going to be DFS with I minus 1, and here it's going to be j plus 1. Because if we unselect it, we're going to have a distance. From the beginning, the distance is 0. Now the distance becomes 1, and then the distance is going to become 2. But this j can never be 2. If the j equal to 2, the j plus 1 going to be 3. So this means the distance is more than 2. This means the window size is more than 3. It is not possible. Yeah. So we are just checking the window size. It can never be more than more than 3. Yeah, even though here it said it is 3 or more, but it doesn't matter. We just fix the window size to be 3. If the 3 meets the conditions, definitely 4 or more meet the conditions. Yeah. So finally, we're gonna return this result. Yeah, I think basically that's all about it. So here is unselect. So for the next number, if unselect, we're gonna still jump to the next number, to I minus 1. But if we choose this number to be unselect, it means we're gonna add the distance to 1. So they're gonna plus 1. Yeah. So this means for the current number, if this is selected, this one can be unselect, and this one can be unselect. If this one is selected, the next one can be unselect and unselect. But we still have the opportunity to select this one. If we select one, this means this one will be unselect and this one will be unselect. But definitely we're gonna choose the minimum of all the 3 different cases. Yeah, this is why we're gonna choose the minimum of the different cases. Now let me just submit it to check if it works. Yeah, so this is the error check. Now as you can see it works. Now let me just submit it to check if it can pass. As you can see it passed for all testing cases and it's pretty fast, and the time complexity is basically O(n). Basically it is I times j. I is the length of the nums array and j is equal to 3. So basically it is O(n). Thanks for watching, see you next time.